HNO2, because for that one we didn't have to rearrange anything. So for this one, actually, the Lewis structure for OCN. So this is going to be a little bit trickier, because just like the other one, we might have to do some rearranging. So let's actually start with CN, but let me just write down the question. OCN minus. So once again, starting at, look at the periodic table, it's all going to be nicely on after the helium. So oxygen is 2s2 2p4, carbon is 2s2 2p2, nitrogen is 2s2 2p3, really close to each other, but 5 here, 4 on the carbon, and 6 on the oxygen. So in total we have 6 plus 4 plus 5, and then because there's a minus here, it's going to be plus 1 more electron. So that's 6 plus 4 plus 6, that's 16 in total electrons. Okay, so just start with the cyanide, right? That's what Cn minus is. Okay, so that one typically is just a 4 plus 5, and then plus that minus, right, plus that electron, it's going to be 10. So we have C and N. Okay, and so it still needs 1, 2, 3, and nitrogen is 1, 2, 3. Okay, whoops, sorry, it's only showing 1, so 1, 2, 3, 4. Okay, so with that being said, it looks quite unstable right now. But remember, there's just one more electron thrown in there. So if we did this and that, and then these ones went in as well, and then you'll be able to actually see the picture now of where it's carbon, N, and because we have that one electron we haven't accounted for just yet, it's going to be right there. So let's see first if we have this correct. We have nitrogen, which is going to be 5 minus 2 plus 6 over 2, 0 indeed. And carbon is 4 minus, it has a 2 plus 6 over 2. So it's going to be minus 1, which makes sense because exactly there's an extra negative, as in there's an extra electron. So that is what cyanide looks like. Okay, now how would we throw in an oxygen? Okay, it may be possible, because right now this has 10, if we threw in the oxygen attached to the carbon, right? Okay, alright, and now it's sharing 1, so carbon still needs that 1 extra one to be that 5, because right now it's sharing 3 with nitrogen, 1 with oxygen, and 1 more, because that's what it was in the, because 2 plus, did I put, yeah, 2 plus 3, that's 5, that's how it has 5 there, and the oxygen is sharing 1 right now, but it still has 5 more to account for. So 1, 2, 3, 4, 5, 6. So what's going to happen is that this actually will go in here, this will go in there, and now, ooh, would it? It would not, because that would actually break the octet rule. So in order to just not try to upset the octet rule and move the actual electron to just a more stable environment, because oxygen wouldn't mind actually having that negative, so this carbon is going to go, I guess it's easier just to draw it at the bottom. This is going to actually just move over to the oxygen. Okay, because if we counted before we moved anything, we actually still have 16, because it's 2, 4, 6, 8, 10, 12, 14, 15, 16. So exactly, that would move there, and now we have C okay, nitrogen, and then because now, whoops, I forgot the actual bond, bonded to the oxygen, okay, now the oxygen is going to have this, so this right now should be the OCN. Now let's actually do the math real quick. Nitrogen stayed the same, so we don't have to do that again. Okay, carbon now is going to be 4 minus, is now sharing 8, okay, over 2, so it's going to equal 0. Perfect. But where's that -1 charge? Let's look at the oxygen. 6 minus 6 plus 2 over 2, because it's only sharing 2 electrons. That would be 7, so it'll be -1. And that's where that negative is on the oxygen. Okay, that's where the negative is, and exactly that's why this whole thing is negative. Okay, so that is the Lewis structure for OCN. Let's see how we did. Determine the central atom. Typically it's carbon, because it can create the most bonds. They have a lot of rules here. You see how we kind of troubleshoot it though? That's also a way to approach it, because sometimes the rules, if you try to be formulaic, you can end up getting stuck and not know how to change it around. Based on the last question we did, where it was HNO2, I realized that maybe sometimes it's good to start step by step, because exactly we were able to get cyanide, which that is CN, and then we were able to now see how adding an oxygen would change cyanide, because we see that it wouldn't really make much sense to go on the nitrogen part, because nitrogen is already stable and balanced, but the carbon is where the -1 was. So yep, that is exactly what we have. I got scared for a second because I don't have it in terms of bonds. I have it in Lewis dots, but exactly 3 pairs, which is a triple bond, exactly, and then we have just 1 bond sticking out the carbon, and exactly the negative is on the oxygen. So yeah, and yeah, so that is going to be the structure for, let me see here, exactly, just looking at the rest of them. This nitrogen here is actually, it doesn't really explain why it doesn't work, but it doesn't work even though it is overall, the oxygen is 0, carbon is 0, and they're just 1 minus 1. The reason why that doesn't work is because we already actually were able to solve that issue when we did cyanide. Nitrogen was nice and comfortable, so making it now, I guess regressing back to it wouldn't make sense, because we established that there is a triple bond between the carbon and the nitrogen. So yeah, now as well as question 24.